I'm Miguel V. This is Rogelio E and Elliot M, and today we have a presentation on radioactivity. So we're going to be talking about the history, the type of nuclear reactions, the type of radioactive decay and emissions, how to balance a nuclear reaction, right, and the difference between fusion and fission, and how the process of fission is used in power plants, as well as the pros and cons of using nuclear power. So without further ado, here's a presentation by Elliot and Rogelio.
The history of radioactivity starts in 1896 with Henry Becquerel, who was using the natural fluorescent minerals to study properties of X-rays. He exposed potassium uranium sulfate to sunlight and then placed it on photographic plates wrapped in black paper, believing that the uranium absorbed in the sun's energy then emitted it as X-rays. His hypothesis was disproved in the 26th and 27th of February, when his experiment failed. Becquerel decided to develop his photographic plates anyways. For his surprise, the images proved that the uranium emitted radiation without an external source of energy such as the sun. Becquerel had discovered radioactivity. Okay, so today we're talking about the types of radiation. The types of radiation is alpha, beta, gamma, positron emission, and electron capture. Now for alpha decay. During alpha decay, an atom spits out 2 protons and 2 neutrons from its nucleus. This is called an alpha particle. Alpha decay usually happens in larger, heavier atoms. The symbol looks like a helium because helium-4 has the same number of protons and neutrons as an alpha particle. Since alpha particles have 2 protons and no electrons, they have a net charge of 2+. During alpha radiation, an atom's proton count drops by 2 and forms a new element. Now for beta radiation. In beta decay, a neutron sends its electron, ejecting from the nucleus at high speeds. The result of it is that the neutron turns into a proton. Beta decay increases an atom's electron count by 1. During beta radiation, an atom's proton count grows by 1, once again, which makes it a new element. Now for gamma radiation. Gamma radiation is an electromagnetic radiation similar to light. Gamma decay does not charge the mass or charge of the atom from which it originates. Gamma is often emitted along with alpha or beta particle ejections. Now for positron emission. A particle that is a nucleus can emit during a decay in a positron. It is a proton in the nucleus that is converted to a positron. Positron is the same mass electron with opposite charge. Now for electron capture. Electron capture is a process in that unstable atoms can use to become more stable. During electron capture, an electron in an atom's inner shell is drawn into the nucleus, where it combines with the proton, forming a neutron.
So today I'm going to talk to you about how to balance nuclear reaction equation. So first, you analyze the problem to see what you are trying to find. In this case, the element that is produced, you put the mass number in the equation and solve for the mission number. Thirdly, you put the atomic numbers in the equation and solve for the mission number. In case the mass number is 234, the atomic number is 92. So the resulting element is uranium.
So what are the two types of nuclear reactions? So the two types of nuclear reactions are nuclear fusion and nuclear fission. So first, nuclear fission, that occurs into more heavier nuclei, which means that they have a mass number greater than 60, and in the process they are split into smaller nuclei in order to stabilize. Nuclear fusion occurs to nuclei that are lighter, meaning they have a mass number lower than 60, and so in that process, 2 or more nuclei bond in order to create one nuclei that becomes more stable. So in both of these processes, large amounts of energy is released. So we use this to our advantage and use this for other purposes. And examples of these reactions include the sun, which is a series of fusion reactions, power plants in which we use fission reactions to create energy. So, how does the process of nuclear fission occur in nuclear power plants? The process begins in the nuclear reactor, where a fuel, usually uranium oxide, goes through fusion while being controlled by certain rods made of cadmium or boron that control neutrons that are being released. So the actual fission process is begun by a neutron emitting source. A reflector is used to reflect these neutrons towards the core so they can react with the fuel elements. A coolant, usually water, is used to carry off heat that comes from this reaction in order to heat other water into steam that moves turbines and generates electricity for us to use. Alright, so now that we know how to use these nuclear reactions, we can go over some pros and some cons that actually come from using these reactions. So first, the pros. The first pro is the large amounts of energy that is released through these nuclear reactions. So these nuclear reactions release huge amounts of energy that can be used in a world like this, where there's a huge amount of appliances and technologies. So we're able to use it to our benefit and power them up with energy that comes from nuclear reactions instead of using other energy resources. So the next pro is the fact that we can use these reactions in scientific experiments and for industrial purposes. So for example, we can use neutron activation analysis in order to detect trace amounts of elements in certain samples. And well, the cons is the fact that radiation can actually be really bad for human health. So this is due to the fact that radiation can damage and even completely destroy cells in the human body. However, this can be used to our advantage because we can aim this to more unhealthy cells and use them to treat things like cancer, because you're able to point them more towards cancer cells and other unhealthy cells in the human body. But another con is the chain reactions that can come from using fission. So in elements like uranium, when they go through fission, they release two neutrons that can also cause another fission reaction. And this can go on and on and on in a chain that cannot be controlled, and there's large amounts of energy that is being released, and this can result in things like atomic explosions, which of course are not good.